To finish up, this is homework number 6, right? Yeah, homework number 6. So, homework number 6, question number 5. U.S. $1 bill valued at 0.8791 Chinese yen. Okay, so $1 valued at 0.8791. 87. How do you spell yen? Or yuan? Is that how you say that? Is that yen? Yuan? Anybody know? Some kind of Chinese currency. All right. So the question is, on a particular day, what was the value of $20.22 American dollars? So $20.22 was, on that day, how much yuan in Chinese currency? Okay, so how are we going to do it? What's needed to solve this problem? What are we going to do? Yeah, so we could, there's probably a, we could just do that. We could, how about equal fractions? Does that sound good? Set up two equal fractions. So you can just put dollars over, whatever they're called, yuan. And so that's $1 over 0.8791 yuan equals $20.22 over X. Right? Two equal fractions. Really, we could just, it's going to end up being just multiply 0.8791 times 2022. Huh? You can probably see that. If you just want to do that, great. Just crank it out. You don't need to be so formal. I'll go through the formalities, though. Just show you it's equal fractions again, so proportion. Diagonal. 1 times x is 0.8791 times 2022. Somebody have that in their calculator? Is it like 19, 18, 17.77? So it'd be, oh, no, that's not dollars. That's yuan. How do I know that's yuan? Because that was on the bottom, huh? The x was on the bottom, yuan were on the bottom. We good? Easy enough? Now, there's a lot of ratios in this section, right? Just two equal fractions. Proportions, they're called. That dot there is multiplies. Everybody see that? So it's 8.6 times 10 to the 6th. What is that called when numbers are written in that format? Scientific notation. Yeah, that's called scientific notation. Scientific notation. So, in other words, it's a different system of saying numbers. So it'd be like me saying one or uno. I'm saying the same number in two different languages. That's what, regular and scientific notation are like. They're just two systems, two notation systems in which you can say numbers. So what they're asking me is, what is the same number? How do they put it? They say convert to decimal. Yeah. So let's convert to decimal. Decimal is like regular. So let's convert to decimal. And decimal just means regular. That's the word we use for regular, right? Because we have a base 10 system. As you know quite well, decimal. We're in the decimal, decade, 10, decimal system. So, how do you convert that number, that 8.6 times 10 to the 6, to like a regular number? What do you do? Any ideas? I'm going to take the 8.6, and what am I going to do? What's that 10 to the 6 thing going to do? What happens when you multiply a decimal number, by 10? Where's the decimal go? If I go times 10, where's the decimal going to go? One spot, huh? And what if I go times 10 again? Another spot. And so you know what's going to happen, huh? 10 to the 6th power? That's just 6 of these. Times 10, times 10, times 10, times 10, times 10, times 10. It's just 6 of them, isn't it? So every one of those 10s is going to move the decimal one place. So I just take the decimal, which originated between the 8 and the 6. I go 1 Gonna jump 6 places to the right, huh? First jump, and I'm to the edge. So the other 5 jumps are going to do what? What happens when you jump beyond the edge? Going to bring in zeros, huh? Yeah. 1, 2, 3, 4, 5. Does that make sense? 6 jumps. The first one gets you to the edge. The other 5 bring in zeros. So that's going to be 8, 6, and 5 zeros, isn't it? So I'm going to put in commas so we can recognize it. So what is that number? 8,600,000, yeah. So this and this are the same number. They're just being said in 2 different systems. This is the decimal system, regular, and this is scientific notation. Why do scientists write numbers that way sometimes? Why would that be convenient for a scientist to write numbers like that? What's that? Makes it, yeah, especially for really big numbers. Like what if you because some scientists anyway, look at things that are gigantic, like, how much mass the sun has or a star's distance away, huge numbers that are like 237, with, just crazy amount of zeros. Now, what if you measured, how far away some star is, and you're like and you're communicating to your science friend in lab, and you're saying, how far away is that star? 237 0 0 0 0 0 0 0 0 0 0 0. That's not a very good way to communicate, would it? You'd be like, wait, how many zeros was that? Instead, if you said 2.37 times 10 to the whatever that is, 12 or whatever, much clearer, huh? Way to communicate super big and also super small numbers, like biologists who measure the width of a cell and things like that, where it's 0.00000000075. It's how do you write numbers like that? You'd say 7.5 times 10 to the what? How do you get the decimal to go backwards? Negative whatever, 10 spots or whatever. Yeah. So it's just a nice way to communicate really big or really small numbers, which some scientists deal with. Yeah. 26 what? The distance between 2 planets. 26. What is it? Is it a million? What helps me is to make it from the beginning. So I'll go 3 zeros. If I put a 26 there, that'd be 26 what? That'd be 1,000, huh? So then I go, okay, so let me add 3 more zeros. If I put a 26 there, that'd be 26 million, wouldn't it? Right, because that's what comes next. And then, so if I put 3 more zeros, this is 26 billion. So this is 26 billion. Anyway, we're not supposed to do that. We're supposed to write it in scientific notation. So what's scientific notation? Let me go to a fresh screen so I can write that out clearly for you. So it's 26 with 9 zeros, 26 billion. Okay, and they want me to write it in scientific notation. Write in SN, scientific notation. So scientific notation, what is scientific notation? Well, let me give you 2 parts to it. You put the decimal after the first number that's not 0. So you put the decimal after the first number that's not 0 times 10 to some power, which tells it to go back to where it really belongs. So that's scientific notation. You put the decimal after the first number that's not 0 times 10 to some power that'll tell it to go back where it really belongs. All right, so here we go. Let's do it. So we're going to take this 26 billion. By the way, right now, I don't see a decimal in 26 billion. But it's really there. Where is it right now? When you don't see the decimal, where is it? Yeah, and I always say it's like a period in a sentence, right? If somebody writes a sentence, forgets to put the period on, you know where the period goes. It goes at the end. Same thing if somebody doesn't show the decimal, huh? It's really there at the end. Totally, you got it. Okay, now let's write it. So this is decimal, normal way of writing numbers, right? The decimal system. Now let's write it in scientific notation. So in SN, where am I going to put the decimal? Between what 2 numbers? 2 and the 6, right? Because you put it after the first number that's not 0. 2 is the first number that's not 0. So put it between the first 2 numbers that aren't 0. and then you go times 10 to some power. Now, what power? Whatever power will tell it to go, that decimal, to go back where it really belongs. Because the decimal doesn't really belong between the 2 and the 6. The number's not 2.6, right? That's artificial. So if you put it here, what would you need to tell it to do? Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Places to the right, huh? Is that good? So 26 billion, that's a big number, isn't it? 26 billion. How many, so if you had 26 million, remember we're talking about, there's 26 million. Right there. How many times bigger is 26 billion than 26 million? Yeah, good, because it just adds 3 zeros, huh? Good observation, right? When you go from million to billion, it doesn't matter what the number is. It could be 26, it could be 34, whatever. When you go from million to billion, you add 3 zeros. That's 9 zeros instead of 6, huh? You add 3 zeros. Whenever you add, what makes you add 3 zeros? What do you got to multiply by to add 3 zeros? 10 to the third, as was being said, or 1,000. Same thing, 10 to the third is 1,000, huh? So basically, it's 1,000 times bigger. Does that make sense? So if you go from million to billion, that's 1,000 times bigger. That means 1 billion is 1,000 millions, isn't it? I heard one of my students was telling me the lottery or something is up to $1 billion. Is that true? Billion? So, yeah, so a billionaire, think about this for a minute. A billionaire has $1 million how many times over? 1,000. Are you catching me on that, right? So 1 billion is 1,000 millions. So it's always, so then the next level, you would go up to trillion, right? That's what comes next. So what if we had to put in 3 zeros here? So this will be, and I'll put a 26 here. 26 trillion. So we added 3 zeros again, didn't we? So whenever you go from one level, that's million to billion to trillion, or even I could start before at 1,000. Back here I could put 1,000. That's 26,000. So whenever you go from one level to the next, you're adding 3 zeros, which means you're multiplying by 1,000, huh? So in other words, and so 26,000, that's 1,000, 26 million is 1,000 times bigger. 26 billion is 1,000 times bigger. On you go. In fact, let me just make them 1 to make it simple. Let me make sure I'm making this point. So this is 1,000, as you know. This will be, I'm going to run out of room, aren't I? I didn't leave enough space. Let me start with the biggest. That'd be better. So this is a big number. Is that it? What is that? Is that a billion or a trillion? That's a billion, huh? So there we go. There's a trillion. So now I will shrink it down. And then I'll shrink it down. And I'll shrink it down. There we go. So 1,000. I want to make sure you have a good feel here of big numbers. 1 million, 1 billion, 1 trillion. Okay? Every time you add 3 zeros. So that means as you go from level to level to level, it's 1,000 times bigger. So like I said, a billionaire, like Bill Gates or somebody, has $1 million 1,000 times. That's kind of a lot if you think about it. If you have $1 million 1,000 times, that means he's a millionaire 1,000 times over. Right? That's a lot. Now, trillion. Do we have anything in life that a trillion would be how much? $1 billion 1,000 times over. Right? So a trillion is 1,000 billions. You tracking with me? And each of those billions is 1,000 millions. That's a lot. What do we have that's trillions? There's only one thing I know. What's that? The national debt. Yeah, that's the only thing that's in the trillions that we commonly talk about. The national debt, right? So millions, billions, trillions, right? Big numbers. There's nothing great about having millions and billions of dollars, though, as we all know, right? I don't know if we all know that, but as the older I get, I see money. You know, it's the famous song as it goes, money can't buy me love. It's true, isn't it? right? Money doesn't really deliver happiness. All right, but anyway, let's go on. What is it? So how many zeros in a trillion? I mean, trillion's huge. It's 1,000 billions, and each of those billions is 1,000 millions. So that's big, right? How many zeros in a trillion? How many zeros is that? How many? 12 zeros. And that's gigantic, right? It's 1,000 billions. Each of those is 1,000 millions. Right? There's no trillionaires, right? They can just pay off the national debt. We don't have any of those. No trillionaires. Anyway, so what is 1 with 100 zeros? Can you imagine putting 100 zeros? So this biggest number we've written up here is only 12 zeros. Right? This is 9 zeros. We're talking 100 zeros. That's like crazy big. So what is the number? It's got a special name. Does anybody know it? 1 with 100 zeros after. It's like the biggest number you can imagine, kind of. I guess you could always imagine another one. But anyways, super big. Nobody knows? You know it well. I mean, you might not know it's this, but you deal with it almost daily. And you know the word like the back of your hand and say it often, every week, I would assume. That's what Google is. Do you know that's the guy that came up with the Google website? He was a math person. He actually spelled it different. Google, I think it's something like that originally. He changed the spelling. A Google means 1 with 100 zeros. That's what Google is. I don't know if you ever knew or wondered why that website has that weird name. Google. What's Google? It's 1 with 100 zeros. It's crazy big. So what was the person saying when they made that website? They were saying, my website is going to go everywhere instantaneously in search, which is what Google does. Right? That's what he was saying by giving it that name. 1 with 100 zeros. It's a Google. I remember when my kids were young, being the sons and daughters of a math teacher makes them a little nerdy at times, I think. And I told them that. I remember them at different times. They'd talk with their friends. Their friends would go, I want to have 1,000 cookies. I want to have 1,000,000 cookies. And I heard a couple times my kids going, I want to Google cookies, as if they thought they were cool because they knew that little information. It's just here, 5 times 10 to the 14th. Okay, yeah. So number 9. Let me write it a little bigger for you. So 5 times 10 to the 14th, 3 times 10 to the 17th. Okay. So 5 is part A. Part A times 10 to the 14th times 3 times 10 to the 17th. 3 times 10 to the 17th. They want me to multiply. Those are multiplying, right? Times, parentheses, times. They're saying, hey, multiply and write the answer in SN, scientific notation. So they don't want the answer to be in like normal. They want the answer to be in scientific notation. All right, I'm going to try to trick you. Well, I'm not trying to trick you. The program's trying to trick you. I'm going to try to help you. But let's see if you can handle the trick without even any help at all. Give it a try. See if you can multiply those numbers and write the answer in scientific notation. It's 5 times 10 to the 14th, 3 times 10 to the 17th. I bet for sure you can get super close, and then if I just help you with one thing, you'll have it. All right, so any thoughts as to what we should do? How do we make that thing scientific notation answer? How do you multiply those? Can I just multiply the 5 times the 3? Yeah, absolutely. 15. And then what do you do with the 10 to the 14th and the 10 to the 17th? What would you guess? Add the powers. Right on the money. Add the powers. So whatever, 14 plus 7 is that 31? So 15 times 10 to the 31. Right, so let me just write that. So step 1, multiply numbers in the front. And step 2, add the powers. Right, because remember that old rule from algebra, same basis, multiply. You remember like x squared times x cubed is x to the 5th. You add powers. Remember that rule? So it's the same thing for tens, right? When you have a couple of tens, they're the same base. With a 14 and a 17, the powers add. It's just like x squared times x to the 3rd, powers add to be 5. Same rule. Anyway, that is really good if you get to there, but it's not quite right. So here comes the real trick. Why not? I mean, what in the world that's it, right? That's scientific notation, isn't it? That's what they wanted. They wanted scientific notation. It's not quite scientific. It's super close. There's one thing wrong with it. What is it? Anybody see it? Yeah, good job, good eye. Yeah, look back here for a second where I wrote the definition somewhere. I can't remember where. Did I ever write it? Yeah, did I write it somewhere? Did I just say it? Oh, there we go. There it is. Yeah, put the decimal after the first digit, huh? Yeah. So that's where's the decimal right now? That 15 looks terrible. Where is the decimal on the 15? It's like a period of sentence. It's right there, isn't it? It's right there. It's not between it. So it has to be there to officially be in scientific notation. That's just their rule. They could have made whatever rule they want. They just said, we want it here. So I have to put it there. Now, put on your thinking caps. What am I going to do here? I'm going to do what I always call plastic surgery. I'm going to remove the wrinkles. I'm going to make this look different without being a different value. We do that a lot in math and science. I don't know if you've noticed that. For whatever reason, we have to change the way something looks, but we're not changing the value. So I'm going to change the way this looks because it doesn't have the right look. The decimal is supposed to be between the numbers. That's just the rule, for scientific notation. But I can't change the value. In other words, I can't just say, okay, and then, it's still 10 to the 31. No way. That'd be a different value, right? That's different. So you can't change the value, but you must change the look without changing the value. Remove the wrinkles, but keep the same value. So how do I do that? It's not 10 to the 31. What is it? 10 to the 32. What makes you think that? Carissa. Right? Carissa, yeah. Because what's that?
Over 1, you should add 1 power to it.
Nice. I like the way you think. That is good thinking. Yeah, she's exactly right. To keep think about what did we do with the 15 when we made it 1.5? Did that make it smaller or bigger? When you say 15, you can have 15 candy bars. My analogies are always candy bars, aren't they? 15, always a little lecture. 15 candy bars, 1.5 candy bars. That's less. That's way less candy bars. So we made that number smaller. So if we want to keep the whole thing the same, remember I want to keep the same value, just make it look different. I want the whole thing to be same value. So if I make part of it smaller, if I make that part of it smaller, then I've got to make the other part of it bigger so that overall, no change. That's right. Good job. Make sense? That's the same value, just looks different now. That's what you got to do. All right. Shall we try another one of these? Is that good? So otherwise, just multiply the numbers to the front, add the powers, but then do that little fix at the end. So now we're dividing. Last time we multiplied two scientific notation numbers. Now we're dividing them. So really, if you want to write it vertical, I think it might be easier. So you don't have to, but I think you might like that. So I'm just going to write it like this. This is what dividing means, right? It's a fraction, one thing over the other. So I'm going to write it that way. So if you had to totally guess, remember on the last one, what did we do? We multiplied the numbers in front, and we added the powers, right, when we were timesing them. So now, what do you think I'm going to do? What am I going to do with the numbers in the front? Divide them, right? And what am I going to do with the powers? Yeah, you got it. Subtract them, right? Subtract them. Now you know why that rule is true. Let me make sure, because in this class, I want to leave nothing to magic, because you guys are going to be masters of this and teach others. So let me give you the reason for everything. 10 to the 5th, 10 to the 3rd, isn't that what they mean? And see the cancel? That's why we subtract. That's what's really happening.
It's supposed to be a 15, not a 5.
Oh, yeah, thanks. 15, so this should be 12. I don't want to write out 15 tens. You get the idea, though, right? That's why the subtraction rule is true, because they're really canceling, huh? So anyway, yeah, that's right. Now, do I need to do any extra special fix on this one, or is he just good the way he sits? He's good, because where's the decimal? Right there, which is after the first number, the only number. So it's good, huh? Don't need to fix that one. Make sense? If that was like a 43 or something, and the decimal was therefore there, I would need to move it back, which means increase the other number. I would need to do the little fix. So everybody see why? Let me go back and compare. See the last one, if you go back, see the last one came out 15 at first. So the decimal was not where it belonged. But this one, the decimal's right there. It's just one number, so it's good. All right, you So I'm going to make it a big, I just think it's easier to write as a big fraction. So I'm going to do that. So it's going to be 3 times 10 to the 8th times 2 times 10 to the 9th over 3 times 10 squared, right? Whatever you're dividing by goes on the bottom. I did that right. Oh, I did it again. Look at that. I did it again. That's what I found with my own mistakes, that they repeat. They're not as random as one might think. Okay. So anyway, so what do I do now? Can you do that one? What's going to happen? Any ideas? What do we do? How about the 3, 2, 3 thing? What about those? Any more?
Multiply the 3 and 2 and divide by 3.
Yeah. You go 3 times 2 is 6. And then divided by the 3. Going to be 2. Or we could have just what? Just canceled it. Either way, it's good to do it. Going to get a 2, huh? Either multiply and then divide by the 3. Or just cancel the 3's. It's going to be 2. Now, what do we do with the 10 power thing? Well, ones on the top, what do they do? Add over 10 to the 12, and then you subtract, huh? 10 to the 5th, done. And that one, does that one need to be fixed? Or is the decimal where it belongs? Yeah, it's just one number, so the decimal is already after the first number, the only number. So we're good. Is that good on that? Just add the powers on the top, subtract the 1 on the bottom, multiply the out front numbers on the top, divide the out front number on the bottom. Okay, so round this number to the nearest, first off, nearest hundredth. So you know where the 100th place is. So here, let me write the number out a little bigger. 377.516. Okay, so let's find the place. So on A, we're talking about the 100th place. So this spot is the 10ths. This spot is the 100ths. So how do you round? You know how to round. You circle the place you're going to stop at. We're going to stop 2 places after the decimal. Hundredths. 100 has 2 zeros on it. So that makes sense. 2 places after the decimal. You look 1 to the right of the place you're going to stop at. And if the 1 to the right is 5 or more, up you go. You know that, huh? So 377.52. There it is, rounded to the nearest 100th. Good. Want to try the next one? Round to the nearest 10th. Same number. Now you're going to round it to the nearest 10th. So 5, 1, 6. 10th. This is the 10th place, right? So circle that place. Look 1 to the right. If the 1 to the right is 5 or more, go up. Otherwise, leave it. So what am I going to do on this one? Leave it. 377.5. Good. How about the next one? Nearest unit. Now, what do they mean by unit? What place? The ones place, right? That's how they say the ones place. Units. It's kind of, I don't know, it's kind of a weird thing to say, but that's what they mean. So they mean the ones place. So right here, huh? So that's the ones. They call that the units place. So what do? Circle the place you're going to stop at. We're going to stop right there. There's going to be nothing after that spot. Look 1 to the right. If it's 5 or more, go up. So what's my number? 378, huh? Because that number, think about money. $377.51 is closer to $378 than it is to $377, huh? So we're rounding to the closest. Okay, how about this? Nearest 10. Now we're going further to the left. So let me I must just erase the whole thing. All right, so nearest 10. So we're doing 377.516. So find the digit in the tens place. This is the ones. This is the tens. So circle the digit in the tens place. Look 1 to the right. If The one to the right is 5 or more, go up. So what am I going to do? Is it 38? No, not 38. What is it? 380. Right? You still have to keep the value. You know what I mean? In other words, they're saying, think about money. If you're saying, I'm going to pay a bill, what's the bill? $377.51. I only have $10 bills. How much am I going to pay with $10 bills? $380, huh? See how that's rounded to the nearest 10? It's closer to 380 than it is to 370. Right? Does that make sense? So any places left over, you have to put in zeros, don't you? To round to the nearest 10. Want to try the last one? 377 rounded to the nearest 100. So round to the nearest 100 on that one. So last one. So 377.516. The 3 out here is in the hundreds place. So circle the place you're going to stop at. There's going to be nothing but zeros after that spot. Look, 1 to the right, 5 or more go up. So what's my number? 400. Right? Isn't that the nearest 100? Isn't 377 closer to 400 than 300? It's the nearest 100, huh? Is that good? A little advanced rounding from both sides there. Okay.